Okay, so part B of this question is just to find the inner products between all the combinations of them, which by now should be a fairly trivial task. I'm not going to go through all of them because at this point, again, it's a little bit tedious. But if there's any of these combinations that you want me to work out that I skipped, let me know and I will do so. Or if you just want me to go through all of them, then I will do that also. But let's go through a couple of them first, just for an example. So let's just do one inner product with itself, which we know should be 1 because it is normalized. So just inner product with itself. So we'll take the bra state of this first one here, which is going to be 1 over root 3 up minus I, because complex conjugate, so minus I root 2 over root 3. And inner product that with itself. So we'll do the ket state of this. So 1 over root 3 plus I root 2 over root 3. And this is up and this is down. Okay, so our up and our up, we have 1 over 3. And those cancel. And then we have a minus I squared 2 over 3. And an I squared is -1, so a negative and negative cancel out, so we have 1/3 plus 2/3, which is 1 that we expected. Okay, so let me just do one more. Let me pick what is probably the hardest combination, which looks like it'll probably be maybe 1 and 3. 1 has an I and 3 has an E to the I. So let's do those two. So let's do 1 inner product with 3. So again, we'll do the bra state of 1, which would be 1 over root 3 up minus I root 2 over root 3 down. And these should be bras. Up and down. Okay, and then our ket state for 3, which is 1 over root 2 up plus e to the I pi over 4, 1 over root 2 down. Okay, so we have our up and our up, which is going to be 1 over root 3 and root 2 combined to make root 6. And then our minus, minus and minus. So it would be minus, do I e to the I pi over 4. We have a root 2 in the numerator. And on the bottom we have a root 3 and a root 2 again to be root 6. Okay, so let's go ahead and first we'll pull out the 1 over root 6, and then we have 1 minus I e to the I pi over 4 root 2, and we can just worry about this part right here. So in order, what did I just do here? E to the I pi over 4. Okay, so this part right here is problematic, but if you remember, the e to the ix is equal to cosine x plus I sine x. If you don't remember that, then go back and look at the 1.1 part 3, I believe it was. But it's Euler's formula where e to the ix is equal to cosine x plus I sine x. Let's go ahead and use that and put that in this place right here. So we have 1 over root 6, 1 minus I times, and then we'll fill this in. So it's going to be cosine pi over 4, so our x in this case is pi over 4, plus I sine pi over 4. Right? And then we still have our root 2. Oh, I don't know what that was. Our root 2 here. Okay. And one more. Okay. So 1 over root 6 stays the same. Our 1 minus I stays the same. So cosine of pi over 4, if you look at your unit circle, is root 2 over 2. Plus I sine pi over 4 is also root 2 over 2. And then times root 2. Okay, so you can kind of see what's going to happen here. So we have 1 over root 6, 1 minus I. This is going to be 1. So that's root 2 times root 2 is 2. 2 over 2 is 1. Plus I, same thing. So root 2 times root 2 is 2. 2 over 2 is 1. So that just stays I. And then we can multiply this I out. So again, we have our 1 over 6, 1 minus I, and then we have a minus I squared. And then so the minus I squared is going to be so I squared is -1, and negative cancel out, so that's going to be plus 1. So I'll write out different steps here. So again, we have 1, it should be root 6. 1 at root 6, and then we have our 1 and a 1, so that makes 2 minus I. And that should be our final answer right here, the inner product of 1 and 3. Yeah, I don't think I need to write out each step here. But again, the I squared is -1, negative and a negative cancel out to be plus 1, and then 1 plus 1 is 2, and then you still have the minus I there. So we have 1/6 times the quantity 2 minus I. So those are the two of the combinations. Again, if you want me to do more, I think 2 and 3 might also be a little bit tricky, but it's going to come down to doing the same thing using Euler's formula. So as long as you know that part, then 2 and 3 should be basically the same as this. So hope that helps.